This is the screencast for Learning Target 35, which is to find the roots, all roots, of a quadratic equation. That means we could have roots that are not going to be real. And in this case, when we not have a non-real number, we are taking square root of a negative number. What we are going to really look at is something called the discriminant, which is the b squared minus 4ac in the quadratic formula. This is the part under the radical symbol or under the square root. And that if we are taking square root of a positive number, we end up having two real roots or two real solutions. If that number we are taking square root of is 0, we end up with one real root, and that's because when we take square root of 0, we get 0. If we add or subtract 0 to any number, we get the same number, one answer. If I go to take square root of a negative number, we have 0 real roots, and that results in what we call complex roots. Now, complex numbers, as you can see up here, are in the form a plus bi. I stands for the square root of -1, and as we work through some examples here, we'll show you how to simplify using that I. So let's get to some examples. The first example might give you an equation like 4x squared plus 2x minus 3 equal to 0. And they might ask you something along the lines of how many real roots or real solutions are there. That's kind of the main question we're looking at. So to figure that out, we use what again is called the discriminant, which is b squared minus 4ac. So just like in the quadratic formula, we've got to have our equation equal to 0, which we have. We're going to identify our a, b, and c. A is our number in front of x squared, which in this case is 4. B is our number in front of x, which is 2. And c is -3. So substituting into our discriminant formula, we have 2 squared minus 4 times -3. We would actually calculate that in our calculator, and we would get an answer of 52. Because we are taking square root of a positive number, that means we're going to end up with two real solutions or two real roots. And at this point, we don't care what those answers are. We just want to know how many we're going to end up with. And in this case, that's 2. Same question, different equation. Let's say I have 3x squared plus 7x plus 10 equals 0. Same question, how many real roots? So again, we're looking at our discriminant, which is b squared minus 4ac. A is 3, b is the positive 7, and c is 10. So we have 7 squared minus 4 times 3 times 10. When we calculate that, that's going to give me -71. Now, because I'm taking square root of a negative number, I'm not going to have any real roots or any real solutions, because when we take square root of a negative number, it's imaginary. So 0 real roots would be our answer there. Let's say I have 9x squared plus 42x plus 49, once again equal to 0. Same question, how many real roots? Again, we might want to identify A, which is 9, B, which is 42, C, which is 49. So my discriminant value this time is 42 squared minus 4 times 9 times 49. When we simplify that, we get 0. And when we go to take square root of 0, we get 0. We add or subtract 0, we get the same number. So that means we end up with one real root or one real solution. Now, from here, we might take that a step further and say, okay, actually solve using the quadratic formula. Maybe I'm given this, -3x squared plus 5x minus 2 equals 0. So we're going to substitute into our quadratic formula. In case you've forgotten that, that's a -b plus or minus. There's the b squared minus 4ac under our square root over 2a. A this time is -3, b this time is 5, and c is -2. So x equals, let's see, negative of 5 is -5, plus or minus square root of 5 squared minus 4 times -3 times -2 divided by 2 times -3. Okay, simplifying, that gives me negative 5 plus or minus square root of 1 divided by negative 6. So that is negative 5 plus or minus 1 divided by negative 6. So we have negative 5 plus 1 divided by negative 6, which is negative 4 divided by negative 6. Simplified, that's 2/3. Or I have negative 5 minus 1 divided by negative 6. That's negative 6 divided by negative 6, which is 1. So there are my two answers. I have 4x squared minus 3x plus 8 equal to 0. Once again, using my quadratic formula, a is 4, b is negative 3, c is 8. So we have negative b, so negative of negative 3 is positive 3, plus or minus square root of negative 3 squared minus 4 times 8 divided by 2 times 4. We need to make sure that when we type that quantity under the square root into the calculator, that we remember to use the parentheses around the negative 3 when we go to square. I get the following: 3 plus or minus the square root of negative 73 divided by 8. Now, when we have the square root of a negative number, we can rethink this as the square root of negative 1 times the positive value of the number, which in this case is 73. The square root of negative 1 is represented by I. So what we do is we rewrite this with I in front of my square root, and we keep the positive square root of 73, the square root of positive 73, and we've rewritten it so now we can simplify that square root if possible. So that gives me 3 plus or minus I square root of 73 divided by 8. I can't simplify the square root of 73, so that's actually my answer. I'm done. One more example. We have 3x squared minus 5x plus 12 is equal to 0. Once again, already equal to 0, identifying my a, b, and c, as you can see on the screen. X equals negative of negative 5 is 5, plus or minus square root of negative 5 squared, minus 4 times 3 times 12, all divided by 2 times 3. So that gives me 5 plus or minus square root of negative 119 divided by 6. Once again, we have that square root of a negative number. When we rewrite it, 5 plus or minus, we put I in front of the square root to say I took square root of a negative number, and we change that square root of negative 119 to positive 119, and that's still all divided by 6. There's my answer. And that concludes how to work and solve any quadratic equation, no matter what type of root you have.